Hello everyone, and welcome back to the channel. Today, we're diving deep into a fundamental concept that every network professional needs to know, the three-tier hierarchical network design. If you've ever wondered how large organizations build networks that are reliable, scalable, and easy to manage, this is the secret sauce. By the end of this video, you'll understand exactly how it works and why it's so powerful. So, what is this model all about? Imagine building a city. You wouldn't connect every single house directly to the main highway, right? That would be chaos. Instead, you have local streets, larger collector roads, and then the major highways. The three-tier model applies the same logic to computer networks. It breaks down a complex network into three distinct, manageable layers: the core, the distribution, and the access layer. This separation of duties makes troubleshooting a breeze and allows the network to grow without a complete overhaul. Let's start from the bottom and work our way up. First up is the access layer. This is where your end-user devices connect to the network. Think of your desktop computers, laptops, printers, IP phones, and even your Wi-Fi access points. The switches in this layer, often called access switches, are responsible for providing that initial network port. Their primary job is to control which devices are allowed on the network and to pass traffic up to the next layer. This is where policies like port security and VLAN assignments happen. Essentially, the access layer is the on-ramp to the network for all of your devices. It's all about connectivity. Now, let's move up one level to the distribution layer. This is the middle child of the network family, and it has a very important job. It acts as the aggregator for all the switches in the access layer. Instead of having dozens of access switches all trying to talk to the core, they connect to a distribution switch. This layer is the brain of the operation. It's where routing between different VLANs or subnets happens, and it's where we apply more complex policies like access control lists, or ACLS, to filter traffic. Think of it as the traffic cop, directing data to its correct destination, whether that's another department within the building or out to the internet. Redundancy is also critical here. You'll almost always see pairs of distribution switches to ensure that if one fails, traffic can instantly reroute through the other. At the very top, we have the king of the hierarchy, the core layer. This is the high-speed backbone of your entire network. Its one and only job is to switch packets as fast as humanly possible. You don't do any fancy packet filtering or routing between VLANs here. The core is all about pure, unadulterated speed and reliability. It connects your different distribution layer blocks together and provides the pathway to your critical resources, like your data center or the internet. The core should be designed for maximum uptime and throughput. We're talking about the fastest switches in your inventory, with redundant power supplies, redundant links, and a very simple configuration. If the core goes down, the entire network goes down, so we build it to be incredibly resilient. So, to recap the flow, a user on a laptop at the access layer sends data. The access switch forwards it to the distribution layer. The distribution switch makes a routing decision and sends it up to the core. The core then blasts it at lightning speed towards its final destination. This clear separation of roles is what makes the model so efficient. Now, let's talk about how this fits into the real world, especially when connecting to the internet. No business can afford to have its internet connection go down. That's why we introduced dual internet service providers, or ISPs. You'll have to separate connections from two different companies. This provides what we call ISP redundancy. If one provider has an outage, your network traffic can automatically fail over to the second one. But how do we manage these two connections and protect our internal network from the dangers of the internet? That's where the firewall comes in. Positioned right at the edge of our network, between our core or distribution layer and the ISPs, is a firewall, or more accurately, a pair of firewalls for redundancy. These devices are our security guards. They inspect all incoming and outgoing traffic, blocking anything malicious or unauthorized based on a set of security rules. They prevent hackers from getting in and can also stop internal users from accessing inappropriate websites. In a redundant setup, you'll have two firewalls working in a high availability pair. If the primary firewall fails, the secondary one takes over instantly, ensuring your security is never compromised. So, the traffic flow to the internet looks like this. Data travels from the access through the distribution to the core then forwards it to the redundant firewalls. The firewalls inspect it, and if it's allowed, they send it out through one of the two ISPs. This entire setup is designed for high availability. Let us zoom in on another critical part of any corporate network, the server farm or data center. This is where your company's most important applications and data live, things like your email, server, file servers, and databases. Where do these servers fit in our three-tier model? Typically, servers are connected to their own dedicated access switches, often called top-of-rack switches. These switches then connect directly into the distribution or even the core layer, depending on the size and design of the network. This gives servers high-speed access to the network backbone, ensuring fast response times for all users. Just like every other part of our design, redundancy is key here. Servers often have dual network cards connected to two different switches, ensuring that a single switch or cable failure won't take them offline. Let's tie it all together with a complete picture. We have our users at the access layer connecting via switches. These access switches aggregate up to a pair of redundant distribution layer switches. These distribution switches handle our internal routing and policies. They, in turn, connect to a superfast, redundant core layer backbone. Our server farm is also connected with high-speed, redundant links into this backbone. Finally, to get to the outside world, traffic from the core goes through a pair of redundant firewalls and then out to one of our two separate internet service providers. Every single point in this design has a backup. A failed access switch only affects a small group of users. A failed distribution switch or core switch, no problem, traffic reroutes through its redundant partner. A failed firewall, the other one takes over. An ISP outage, we have a second one ready to go. This is the power of hierarchical design combined with robust redundancy. It creates a network that is not only scalable and manageable, but also incredibly resilient to failure. It allows a business to operate with confidence, knowing its digital infrastructure is solid. And that's the three-tier hierarchical network design in a nutshell. It might seem complex at first, but when you break it down into the core, distribution, and access layers, it becomes a logical and powerful way to build robust networks. Thank you so much for watching. I hope this breakdown was helpful and gave you a clear understanding of this essential networking concept. If you found this video valuable, please hit that like button and don't forget to subscribe for more deep dives into the world of tech. Let me know in the comments if you have any questions or what topic you'd like me to cover next. See you in the next one.